Welcome to this video today on the common and natural logarithms. A common log is just a log function that's going to have a base of 10. Now that might look something like this. Log base 10 of x equals 2. Okay, so you can take common log functions and write them in exponential form just like we've done before. The key thing here is that the base will always be 10, so that's going to be very important. You can also see logs that are common logs written without the base, so that might look like this. Log of 8. This is understood to have a base of 10, so we could rewrite this with the base and it would look like this. Log base 10 of 8. Same thing, written two different ways. And common logs are actually going to be very helpful when you are trying to solve exponential equations, and that's what we're going to do here in these first examples. So remember from the previous section, we could solve exponential functions by making the bases match. So for example, we might have 2 to the x equals 8 to 3x plus 1, and we change that 8 to be 2 to the third, and then we would just deal with the exponents. Well, now we're looking at an equation where we can't make the bases match. So we're kind of stuck at the moment, and the easiest way to deal with that is to take the log of both sides. So if we take the log of both sides, it's going to look like this. Log of 4 to the x equals log of 19. Notice I didn't write the base because we're assuming we're using a base of 10. And now because I have logs on both sides, I can use my log properties that we've talked about previously. So I've got this exponent here at the top, and we know anytime we have logs, the exponents can move to the front. And that makes it easier for us to solve for x. And if I rewrite this, it would look like this. X times the log of 4 equals the log of 19. And remember, log 4, log 19, those are just numbers. So don't let the word log confuse you, because if you were to type that in your calculator, you're just going to get a decimal answer. Okay, so now if I want to solve for x, all I have to do is divide by log of 4 on both sides. And on the left side, those will cancel, and we'll be left with x is equal to the log of 19 divided by the log of 4. And then you just have to go to your calculator. Be very careful when you type this in your calculator that you use parentheses. So you'll type log of 19. Make sure you close the parentheses around it, and then you can say divided by log of 4. And when you do that, you get x is equal to 2.12. So make sure that you type it in your calculator and that you get the same thing. And if you don't, make sure you ask me in class and I can see how you're typing it in and make sure you're doing it correctly. Okay? So there's our first example of using common logs. Let's try a little bit more of a complex example. Notice here we've got two bases that do not match, and there's no way we can make them match very easily. So we're going to go ahead and use our common logs. So I'm going to take the log of both sides. So I'm going to say log of 4/5 to the x equals the log of 6 to the 1 minus x. And again, we're using our exponent rules. So I can take my exponent here and move both of those to the front of each log. And when I rewrite that, I'm going to have x times the log of 4/5 equals 1 minus x times the log of 6. Now, here's the big problem on this example. When you're solving, you want x on its own. But here I have two x's in two different places, and they're on different sides. So the best thing I can do is try to move all of my x's to one side of an equation. And to do that, I have to do a little bit of distributing. So I'm going to go ahead and distribute this log 6 to both the 1 and the x. And I can do that because log of 6 is just a number, so it's like I'm distributing a number. So when I rewrite this, I'd have x log of 4/5 equals the log of 6, because that's 1 times log of 6, minus x times the log of 6. So this is just because I distributed. Okay, and now I'm going to try to get all of my x's on one side. So what I'm going to do is add this x log of 6 to the left. And I'm going to simplify this. And so if I rewrite that, I'm going to get x log of 4/5 plus x log of 6 equals log of 6. And now I have all my x's on one side, and I have my log of 6 on the other side. So the easiest thing I can do here, logs and adding x's are a little bit different. You just can't combine them like we add normal numbers. Instead, what I can do is I can pull the x's out. Think of it like a greatest common factor. So they both have an x in common, so I'm going to take that x out. And when I do that, I'm left with my logs in parentheses. So I took out a common factor. And because I was able to take out the common factor, I went from having 2 x's to just having 1. So now what I can do is I can combine my logs that are on the left side. And remember, if we see addition in logs, that's the same thing as multiplication. So what I'd have here is x times the log of 24/5 equals the log of 6. And now to get x by itself, all I have to do is divide by the log of 24/5 on both sides. And then you could go, of course, to your calculator and you would type that in. And I believe you get something around 1.14, but you want to double check. Make sure you also close the parentheses after the 6th and then divide by the log of 24/5. That's it for this problem. I know it's kind of long, but if you have any questions about any step I made, make sure you ask me in class. And again, if you need to know how to use your calculator, make sure you show me yours, and I will gladly show you how to use the log buttons. The next thing we're going to use is what we call the change of base formula. And basically this allows you to take a log function and convert it so that all of the logs have a base of 10. And the reason we would do this is because usually most calculators can only be in base 10. So if you convert it, then you can type these into your calculator a lot easier. And this would look like this example here. Log base a of n. If I'm going to use the change of base formula, this would turn into log base 10 of n over log base 10 of a. Notice I didn't write the tens because it's understood to be a 10, so that you just have to know that the base value is going to be the log on the bottom, and the n value here is going to be the log that's on the top. So it basically just turns into a division problem, but all again with bases of 10. And so I'm just going to jump in and show you an example of what that would look like. Here we've got log base 3 of 20, and if you tried to solve this and by putting it in exponential form, you'd have 3 to some power equals 20, but unfortunately there's nothing 3 to the power that will get you 20. That's very nice. So using the change of base formula, we can rewrite this all with bases of 10, and then we can type it into our calculator much easier. So this would be log of 20 divided by the log of 3. And now we can just go to our calculators and then type in log of 20 divided by log of 3. Again, don't forget your parentheses, and that's going to get you 2.73 if you round to the nearest hundredth. And that's it. So very easy formula to use. You just have to remember which number goes on top and which one goes on bottom. I always remember it. The base is on the bottom. Okay, and that is especially handy if you cannot change it to exponential form and solve very easily.